Hi, welcome. Today's lesson is on ion formation. You already watched a video on ion formation, and here are some sample problems of what you might have to do with that information. So take out problem book 307 and a periodic table and follow along. Push pause until you have the two pieces of paper. So welcome back. We're going to do problem 11. And notice it's box diagrams, which we've done before, but what we haven't done before is box diagrams for ions. So they're the same thing. I put in the electrons. The only thing that's different is I have to figure out what electrons I have. And this is based on the charge and the number of protons. So I'm going to draw this a little bit bigger so you can see it. But the first example which was done for you is for the phosphide ion, which was phosphorus with a 3- charge. It has 15 protons, but if it has a 3- charge, it doesn't have 15 electrons. It has 3 more electrons. It must have 18 electrons. So instead of putting 15 arrows, we're going to put in 18 arrows, and you follow the same pattern as we've done for putting in arrows. And the next question it asks you is, what neutral atom is phosphorus 3- like? And so you're going to get out your periodic table and find an atom when it's neutral that has 18 electrons. Well, argon has 18 protons and 18 electrons when it's neutral. So I put in here equals the same configuration as argon. When they have the same configuration, we call that iso, which means same, electronic, which means electrons. So same electrons as the neutral argon. And you'll notice when atoms become ions, they usually become isoelectronic with a noble gas because then they become stable. So what you're going to do with each of these is first figure out how many electrons it has, then put in the correct amount of arrows, and then find out what noble gas that's similar to. So the next one is magnesium 2+. So it has 10 electrons. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the box diagram. And what is that similar to? I look up number 10 on the periodic table, and I have neon. So this is isoelectronic with neon. And you're going to do the same for the rest. This one has some exceptions to the rule, so you can skip it or give it a try. We'll talk about that later in class together. Thanks for listening.